Welcome, let's go through the video to see what this project is about. Let's start with a brief introduction to the domain of the project. This project falls under the category of human action recognition, which is a hot research topic in the field of computer vision. As stated previously, this is a hot research area, and many are focusing on classifying actions considering the whole body as a single unit. Therefore, prior work have already addressed the problem of human action recognition by detecting high-level actions by considering whole body. However, most of those approaches loses finer level of details of limb-level motion relationships, especially inter- and intra-limb level movements of similar limb-level motion actions. Therefore, there is a need to get some more insights just than classifying actions by considering the whole body as a single unit. Human action recognition generally is used in many domains such as surveillance, healthcare, gaming. If we consider the proposed application which gives limb-level insights, it can be used in many domains such as performance analysis of athletes in sports science, in patient rehabilitation in healthcare, for example for monitoring post-stroke patients, in CCTV footage surveillance. These are the objectives that are being covered in the proposed project. The reason to propose a hybrid approach which uses supervised and unsupervised models is to get the benefit out of both to approaches. The project scope is limited to skeleton-based data modalities. Hence, when considering supervised learning-based approaches, nowadays GCN-based approaches have outperformed other varieties in terms of classification accuracy. Hence, as supervised model GCN-based model is being used. The reason to combine unsupervised-based learning approaches is as it has many benefits such as the ability to get hidden patterns which cannot be derived from supervised-based models. This is the proposed methodology after a comprehensive literature survey. It is a sequential process which consists of a base model, extractor and an unsupervised clustering model. As the base model info GCN by Chi et al. Was selected after the literature survey on GCN-based approaches. It is a state-of-the-art model which has accuracies over 90% for 2 skeleton benchmark datasets. The extractor devised extracts 4 intra-limb level embeddings and 4 inter-limb level embeddings. 3 unsupervised clustering models were used, which are topology-preserving dimensionality reduction techniques. Additionally, CMeans, which is a widely used clustering algorithm, was applied on top of the outputs of unsupervised topology-preserving maps in order to do a quantitative evaluation. This is just an illustration used to represent what is meant by intra- and inter-limb embeddings. So, it is visible that each inter- and intra-limb embeddings has 4 embedding extractions. This diagram represents the zoomed-in representation of the place where embeddings are extracted. If explained in the simplest possible way, embeddings are the self-attention weights of the self-attention graph convolution module of the state-of-the-art info GCN model. In this section, the main results obtained will be highlighted. The analysis is done under 2 sections, qualitative and quantitative. In this section, the main results obtained will be highlighted. The analysis is done under 2 sections, qualitative and quantitative. The quantitative results are as shown. After selecting the optimal number of clusters through elbow method, the measures purity and entropy, which are internal cluster metrics, are measured for each segment under each topology preserving unsupervised clustering approach. It is visible that overall a map has performed better compared to other 2 for most of the segments. This is one of the visible insights identified through qualitative inspection. When we inspect the dataset for the actions donning and doffing, which are putting on a coat and taking it off, it was noticed the foot movement was same but the hand movements were different. From the cluster outputs, especially from map plots, it was visible that when considering the hand-to-hand map, the clusters for donning and doffing was separated. But when foot-to-foot maps are considered, the clusters for donning and doffing was not separated. As 3 unsupervised topology-preserving maps were applied, to compare those 3 qualitatively, the percentage of each action under cluster was analyzed. This sample is for foot-to-foot, and we can see that donning and doffing are clustered together near in all 3, and walk around and drop trash are clustered together in XM and TSNE. So in conclusion, the main contribution of this research is extending the existing human action recognition-based state-of-the-art info GCN model to get enhanced insights into finer level of details of intra-amp, inter-limb level motion relationships of similar limb-level motion actions. The speciality is this is a novel hybrid approach which might be useful in many applications. So in conclusion, this research contributes to the field of HAR by demonstrating a novel possibility for finer level of insights into limb-level movement relationships beyond what is currently possible. As future research, further investigations on finer level body segments which are granular than limb level would give more low-level insights. For example, each limb could be separated into bone level for analysis. Further, investigations on the use of enhanced unsupervised models can be researched out. Finally, could research on checking the possibility of using explainable AI integrated to assess the reasoning behind the cluster formations observed. Thank you for watching the video.